Welcome back. In this lecture, we will discuss the differential equation of the type dy by dx is equal to ax plus by plus c upon lx plus my plus n. This is basically a non-homogeneous if either of the c or n is not equal to 0. So we would see the method to solve this differential equation. So now again, this is categorized into two cases. Case 1 is that when a by l is not equal to b by m. So basically the coefficient of x in the numerator upon the coefficient of x in the denominator is not equal to the coefficient of y in the numerator by the coefficient of y in the denominator. So that is one case. In the other case, we take the negation of that is a by l is equal to b by m. So in this case, what is actually happening is that you convert first the given differential equation into homogeneous differential equation of first order, and so we can solve this by the method prescribed for this kind of differential equation. Now here in this case, we can directly with the particular substitution or certain substitution, we can convert this to a variable separable method and we can solve this. So in this video, we will discuss first case 1, and in the following videos, we will discuss this is case 2. We will discuss the next case 2. Okay, so let's discuss case 1 in this video. Given dy by dx is equal to ax plus by plus c upon lx plus my plus n, such that a by l is not equal to b by m. So we will solve for this kind of problems. So in such problems, what we do is that we change the independent as well as dependent variable. In fact, we shift them to certain extent. So what we do is that we put x is equal to the old independent variable. We change it to capital X plus h, and this is the extension that we do, and small y, the new dependent variable, I'll call it as y plus, let me call this as k. Okay, where h and k are constant. Now this h and k are actually we are choosing so that the given differential equation become homogeneous differential equation. So how do we choose this differential equation, this h and k, so that the given differential equation gets converted to homogeneous differential equation? So first let us mark this as equation 1. I should change. Okay. So then if I differentiate this again, I mean we just see dx, the total derivative, then this is same as dx. This total derivative is equal to 0 being constant. Dy is equal to d of capital Y. Okay, so we will change this equation 1. So equation 1 implies dy will be replaced to capital Dy and dx will be replaced by capital Dx. a into x is replaced by capital X plus h, plus b is replaced by y plus k, plus c, the whole thing by L into x plus h plus b into y plus k plus n. So now we will further simplify this and we will put it in the standard form. That is, we will see the coefficient of x, coefficient of y plus coefficient of y and the constant term in numerator as well as in the denominator. So if I see the coefficient of capital X over here, your it's same as a into x plus, from here, from this bracket I take b into y, and remaining other constant term as it has ah as the first term and bk as the second term and constant c as the last term. Similarly, in the denominator you have lx plus by plus this is not b, this is same as I used m, right? So m my plus the remaining term, the constant term, that is lh plus mk plus n. Now you just look at this part which is in bracket. It has ah plus bk plus c, and here you have a lh plus mk plus n. So that's the expression with the unknown h and k which is need to be determined. So what we will do over here, we choose that h and k in such a way such that this bracket and this bracket becomes 0. Once it becomes 0, you will see that you get a differential equation. You get a differential equation dy in terms of capital Y and X, which is homogeneous, because the numerator is a homogeneous. Numerator will become a homogeneous of degree 1 and the denominator will also become homogeneous of degree 1 in terms of capital X and capital Y. We will be solving this for first for capital X and capital Y. So we choose H and K in such a way AH plus BK plus C is equal to 0 and LH plus MK plus N is equal to 0. I'll call this as, this is a system of linear equation with unknowns H and K which you need to determine. So I'll call this as, say, 2. So solve 2 to find the value of H and K, and so this expression, so let me call this as 1b. So 1b reduced to dy by dx is equal to ax plus by upon lx plus my, which is homogeneous. Okay, and you can solve it using the technique we just replace y by vx, and that means I'm changing dependent variable from y to v, and you convert the given differential equation, this differential equation in to the separable variable, solve it for x and y and put it back in the original equation. So these are the working rule to find to solve the differential equation of this form. So let us quickly take one example and see how it works. So illustrative example, solve solve dy by dx equals x plus 2y minus 3 upon 2x plus y minus 3. Let me call this as equation 1, as I'll be referring it maybe in the next further. So first thing I need to check, as you can see that this falls in the category of what we just mentioned. Dy by dx is equal to ax plus by plus c upon mx plus lx plus mx plus n. So if I look at a, it's a by l, it's 1 by 2, and if I look at b by m, it's 2 by 1, which are not equal. So this falls in case 1, and so we will start solving using case 1. So first of all, you need to substitute the value of x as capital X plus h. So that means this capital X is nothing but x minus h, and the value of y as y plus k. So dx become d capital X and dy become, and so the equation 1 become reduces to, what is equation 1? dy small small y will be replaced by capital Y, and here this is d capital X. X is same as x plus h, where h need to be determined. 2 into y plus k minus 3, the whole thing upon 2 into x plus h plus y plus k minus 3. So if we solve this further, and if we write this in the standard form, that is, we are looking for the coefficient of x, that is 1 into x plus 2 into y from here, and plus the remaining term, that is h, from here the constant, from here 2k, and from here minus 3. The whole thing upon, again over here 2x, from here this is 1y, and the constant term, that is 2h plus k minus 3. So that's your dy by dx after substituting. I'll call this as equation 2. So we know we get the hint of choosing h and k. So we choose h and k, says that h plus k, h plus 2k, h plus 2k minus 3 is equal to 0, and 2h plus k minus 3 is equal to 0. Upon solving this, you will see that the value of h is equal to 1 and the value of k is equal to 1. So next, therefore, equation 2 reduces to dy by dx is equal to, what do we have in equation 2? So the whatever in bracket will get converted to 0, and rest all will remain same, 2x plus y, which is homogeneous, and we know the method to solve the homogeneous differential equation. So we will solve this by certain substitution. So the substitution over here is that, so we are solving this now, and then we will go back to the original one. So once we find the value of this y in terms of x, then we can replace the value of y in terms of small x, and value of x in terms of value of y in terms of small y, and value of x in terms of small x, and also we have found unknowns h and k, that also can be replaced. So put capital Y is equal to V into capital X. So you are changing your dependent variable from y to v with this substitution. So that same as dy by dx is same as v into derivative of x with respect to x, that's equal to 1 plus x into dv by dx. And so we get, I'll call this as equation 3 if I have not used that 3 anywhere. Yes. So this 3 become, I'll write down here, it's v plus dv by dx. Okay, now you're changing only your dependent variable. Independent variable capital X will remain as it is. So x as it is, this should be free from capital Y now, plus you have 2y, so 2 into v into x, and 2x as it is, plus y, that is vx. Now if you see the numerator and denominator, you will see x common, so that can be written as, I'll directly write down, oh I missed one term over here, that is x. So after taking this v to the other side and after dividing the common x term, I get dv by dx equals, x gets cancelled, so here you have 1 plus 2 small v upon 2 plus v, and this minus, okay, again I missed x over here, will come over here, the v will come over here as minus v. So that same as writing x dv by dx. So this is now in terms of v and x now, and it's a separable variable, so we are solving it for v to get the value of capital Y. Okay, so that's same as 1 plus 2v minus, this is same as, now after multiplying, 2v minus v square upon 2 plus v, which is same as 1 minus v square upon 2 plus v. So now you can very easily separate the variable. So taking the part of v to this dv, we get 2 plus v upon 1 minus v square into dv is equal to 1 by x into dx. Now you integrate this 2 plus v. Now 1 minus v square can be written as 1 minus v into 1 plus v, s you cannot directly integrate this as it is, so we resolve this term into the partial fraction so that we can write down the integral, and this is same as, we can directly integrate natural log of x plus, I'll call this as log of c, the constant term, as again you will see that this is of the form a upon 1 minus v plus b upon 1 plus v, and so it will again contain log. So you have to write down, okay, let me here, I'll call this as star. I want to resolve this into the partial fraction, so that's 2 plus v upon 1 minus v into 1 plus v. You write it as some a upon the first vector 1 minus v plus, and we are allowed to do this as the degree of the denominator is greater than or equal to degree of the numerator, and b upon 1 plus v. So you can solve this 2 plus v, a into cross multiplying 1 plus v plus b into 1 minus v upon some choices, for some choices of v and v, you will get the value of a, and you can verify that the value of a would be same as, the value of a would be same as, a is same as 3 by 2 and b is same as half. So you just check this. So therefore what star becomes, I can rewrite star as this. From star we have I can split that term, and so the first term under inside the integral will be 3 by 2 upon 1 minus small v dv plus integral 1 by 2 1 plus v dv is equal to log of x plus log of c, and so this is same as 3 by 2 minus 3 by 2, because the derivative of 1 minus v is minus, so that minus is missing, plus half into log of 1 plus v is equal to, I can write down this as log of xc, and so further we can simplify this using the property of log. So this is log, this half will go to this is same as saying log of 1 plus v the whole raised to half, and this is same as saying I'll log of 1 minus v the whole raised to 3 by 2, and this is the difference. So you will have log of 1 plus v the whole raised to half the whole thing by 1 minus v the whole raised to 3 by 2 is equal to log of xc. So after taking inverse on both sides, you get 1 plus v the whole raised to half upon 1 minus v the whole raised to 3 by 2 is equal to simply xc. And so when you square it up to further simplify, you get squaring up 1 plus v upon 1 minus v the whole raised to 3 is equal to cx, being c square x square, right? Further, now you need to substitute the value of first for v, so that is 1 plus, what is v? V same as y by x, capital Y by x, upon 1 minus y by x the whole raised to 3 is equal to c square x square. It's still not over. You just have to, for the final step, you just have to substitute the value of v and y and x. Now you know that the value of x, small x, is the value of capital X, the value of small x is capital X plus h, which is same as x plus 1. So the value of capital X will be x minus h, that is x minus 1, and the value of capital Y is y minus k, that is same as y minus 1. So this further simplified as the last step 1, it's a bigger term, so I'll write it as 1 upon y minus 1 the whole thing by x minus 1 upon 1 minus y minus 1 upon x minus 1 the whole raised to 3 is equal to c square, and this is same as x minus 1 the whole square, if you want. So that's the solution of 1, and if you want you can further simplify at your own risk. Okay, so I would wind up with this. Stay tuned for the next lecture, as I'll be discussing case 2 of the same kind of differential equation. Thank you.